For problem number 69, we're supposed to take the graph of f of x that's given. So this is the graph of f of x. And we're supposed to transform the graph based on what it tells us to do. So down here in part A, capital F of x is defined to be f of x, the current graph, plus 3. And we know that that means we go up 3. So each of the points that we see on the graph of f of x, like starting with this one here, -4, -2, we're going to move that point up 3 units. So we're going to move every point that we see on the graph of f of x up 3 units, okay? So -2 plus 3, so up 3 means 1, 2, 3. That means that that point right there would translate to 1, 2, 3, 4, -4, 1. So we have -4, 1, and then 0, 2, moving up 3 becomes 0, 5. And 2, 2 becomes 2, 5. And 4, 0, up 3, 1, 2, 3 becomes 4, 3. So that's all that means. And if we connect the dots, we have a new graph that has the same exact shape as the old graph, but it's been translated up 3 units. So we do the same thing here for part C. Part C, it asks us to, with a minus sign in front of the f of x, that means we want to reflect the graph of f of x over the x-axis. So reflect about the x-axis with the minus sign out there. So the point -4, -2 would be translated to the point -4, +2. And the point 0, 2 becomes 0, -2. 2, 2 becomes 2, -2. I'll just put the dot there. And 4, 0, since it's on the x-axis, isn't going to move at all. So we would leave it alone. And connecting the dots, we have the graph of p of x, which is equal to the opposite of f of x. All right, on to part E. Now part E, with a 1/2 in front of the f of x, that means all of the y values on f of x are cut in half. And so we have a vertical compression. And so for -4, -2, the x-coordinate doesn't change, but the -2 multiplied by 1/2, half of -2 is -1. So -4, -2 becomes -4, -1. 0, 2 becomes 0, 1. Half of 2 is 1. Again, 2, 2 then becomes 2, 1. Half of 2 is 1. And again, that point on the x-axis isn't going to change at all. That's still going to be 4, 0 because half of 0 is 0. So you could see, basically you take the graph of f of x and you flatten it a little bit, vertical compression, and the slopes of each of the diagonal pieces of that piecewise function are not as steep as the other ones. It's not as high as the other slopes of those other pieces. All right, so finally, I guess I can get all 4 parts on one video. We are graphing in part F, we're graphing g of x, and that is f of -x. Now, f of -x or f of the opposite of x, this means we're going to reflect about the y-axis. So when we replace x with the opposite of x, we're going to be reflecting in the y direction. So every point on the left side of the y-axis will get reflected to the right side of the y-axis. And so -4, -2 becomes 4, -2. Again, the y values don't change on this one because we're reflecting in the horizontal direction, but the x values change. So 4, -2 is that point there. 0, 2 is still 0, 2. 2, 2 becomes -2, +2. -2, 2, and then 4, 0 being reflected about the y-axis becomes negative 4, 0. That's it. And then we just connect the dots. So you plot each endpoint of each piece and then just connect the dots. That is the graph of, that's the graph of g of x equals f of the opposite of x.